Hi everyone, my name is Patryk. I will be talking about Mongo database during this presentation and to be precise about transactions in this database. Also, I will try to share some information about the design of the document and our data inside this database. And also, I will touch a few things, practical things, how you can implement those transactions in the Spring Boot framework, which is the most popular framework. Nowadays, I believe still, maybe many people hate it, but I guess still it's quite popular. And I will describe two problematic designs or piece of codes that can cause potential issues for us. But first, let me introduce myself. Maybe many people don't know me. So my name is Patryk Glowienko. Originally, I'm from Poland, as you can see based on this funny letter in my surname, letter L. And then I moved to the Netherlands. Last year, I joined syntactic. And currently, I'm programming on a daily basis at one of our clients, of course. So it's Albert Heijn in a home delivery project. So delivery of supermarket goods, let's say, from the warehouse to our houses. And also in this project, we are using Mongo database in some of the services. Okay, then it's good to be on the same page. So quick slide, if you are not familiar with this database, let's go through a quick comparison. So when you have SQL database, probably it's like known by heart for you. So we have table. In Mongo database, it's a collection, so different naming, similar thing basically. And then we have a row in a normal table, and of course it's a document in Mongo. And going deeper, we have this document or object that we save, and it has of course fields, so it's like a column. And as you can see, there is like some async transaction thing in both databases, Mongo and, for example, Postgres, and they both should be like async. So atomicity, consistency, like those transactions should be isolated from each other, depending on our settings, of course, and then those should be durable. But in Mongo database, we have, of course, a few complicated things because it's a totally different database than SQL ones. And another important thing to also just share quickly is the definition of the transaction. So for me, transaction is a group of database changes that should be applied together as a unit. So we have many things that we do on the database, but it should be treated as a single operation for the database. So either every operation is applied or none of them. So if we change, let's say, order document and we do something with the warehouse collection, or we manipulate some other data, but third operation failed, is throwing some exception, I don't know why, everything should be rolled back. And if everything is okay, then of course everything should be applied. And it should stay in the database for the rigging operation. That will be later. So it's just one way of providing data consistency in our system, which is quite important, of course. And to be honest, transactions are quite difficult, I guess, together maybe with async programming, concurrency in general, and actually transactions can be quite tricky. And it can be really tricky when your PO or project manager says that every piece of data in every business logic should be consistent immediately, everything should be synchronized on the spot, and like, yeah, whatever, we have high load on our system, many clients want to, for example, pick the same times for the order delivery. Okay, it should be just working correctly every time. So it can be really tricky, it became very tricky in that cases. And it can be especially tricky in non-SQL databases because they are just built differently. So usually we don't have just one server of SQL instance, let's say, like our fancy Postgres database, just one server. We usually have some replica set that has many nodes that cooperate, or maybe we are even in a worse, like we are maybe even in a worse shape, like we have a lot of data, let's say, so then we have additional sharding, so even more complex setup. And let's compare those two approaches or two databases, because indeed they can be, they are quite different. Because first of all, in Mongo database there is totally different implementation inside a database. So there is totally different engine, different logic inside the database, how to handle every operation, how to commit and rollback it. So there is a beast called Wired Tiger inside Mongo, for example. And comparing to Postgres, in Postgres we have transactions that are supported from scratch. From the beginning, they are built in the database, and basically, like some database developer or database guy can say that they are easy, robust, performant. Basically, we can do everything on the database because it's so good and so nice. And in NoSQL database, on the other hand, it can be tricky because transactions might not even exist. So actually, it might not be supported. Maybe there is something like eventual consistency in this type of databases, or maybe there are some restrictions on the transaction. So it's sometimes really hard to make those data consistent. But we are more or less in a good shape with Mongo database because actually transactions are supported. But as you can see, I guess here, only from version 4 of Mongo it was added. So as you can see, many versions, major versions of this database had no transactions at all. So actually at the end they implemented it, they support it, and they say they should work more or less similar way like in SQL. Okay, then I guess we know what is the transaction, we know what is Mongo database, that it has some collections, that we can put data inside this database, it should stay there, hopefully. So then I guess we can just use Spring Boot framework, our favorite one, or the team is just using it, so we have to. And then we are throwing transaction annotations everywhere, because we learned somewhere that when we have this classical service, let's say order service, really complex one, there are some methods in the service, so as I remember, as everyone should remember, there should be some transaction going on. So usually people just put transactional annotation on every method. Okay, it should work, it looks okay. But let's first have a look at the Mongo database docs to dig a bit deeper into this problem and this database setup. So first, interesting thing is that Mongo database says that transactions might not be that performant or efficient in some cases. So it's not like the best way of enforcing this data consistency in our service, or it might be not. Or in some cases, for example, read performance can be really affected when there is a lot of traffic, a lot of clients want to order something in our system, or just we have a lot of RESTful to our server, then maybe we have a lot of reads, a lot of transactions open, so those reads can be really affected. So they say, like, using transactions, potentially we have high performance impact, or it can be like this. But of course they say that transactions work, so they should ensure that our data is up to date, or maybe if something broken in the middle, it will be rolled back. So it looks good, but let's check and have a quick look at this second way of enforcing this consistency in our service, in our database. So we can just embed related data together. And then if we do this, so anything that maybe like comparing to SQL, when we have multiple tables, we manipulate them together, we change them together, but in Mongo we can just put them inside one collection, inside one document, so just inside one object. And then the performance impact should be really lower, so it should be maybe low, maybe moderate, depending on how big is document. So okay, let's follow this for a second and have a look how actually transactions work in Mongo. So in Mongo database, we have a concept of documents and collections, and Mongo says that basically when we have one document and we are making any changes on it, it will be atomic by default. So there is no need for any fancy transactional annotation or any additional setup, it just works fine. So actually when we just embed object inside object and we put things that have any relation and should change together, we just put them inside one document, we can kind of bypass the problem, and then using this denormalized model, not like SQL, many tables, everything is splitted and normalized, we are doing a bit of opposite, just to leverage this single document atomicity for our transactions, for our actually logic, because then we don't even need a transaction for those many practical use cases we have in our system. So it's similar to like domain-driven design concept when you have this aggregate root that should keep things consistent. So we are also here in Mongo. The advice is to put everything that should change together, put everything in one document. So don't be afraid to put like inside order thousands of order lines or maybe some, I don't know, millions can be actually problematic, but maybe hundreds of thousands of history of this order or for this client or whatever. So we can have really big arrays inside this document and it should be performant. It should work fine as Mongo database at least promises to us. But of course, there can be use cases that we can have more complex logic, more complex requirement that indeed when we change the order, maybe some other warehouse collection has to change as well together and be consistent with each other. Maybe we have to change some client data or whatever. So then in those cases, we have to use those transactions. So then the Mongo says that, okay, we support the distribution transaction concept when you have many documents of the same collection or you have many collections. So basically when we are saving many orders together or saving many orders and some other data from other collections, then we can actually use them and apply actual transaction. And then they also say that it is really good to use read-only transactions for some optimization. Then we need to dig a bit deeper maybe to see the differences or just in practice we have to try it out, but they say it's doing something. Okay, so we have more or less a higher level of understanding what is transaction, where it is actually needed, where it is not, what is atomic by default. So we can go to the Spring framework configuration. So first thing that is good to mention and quite important, and people are confused sometimes by this, is that transaction support in Spring Boot is disabled by default. So there is no like transaction created when you just put transactional annotation on the method. It will just ignore it. So we have to explicitly provide a Mongo transaction manager object to our application, and then it should be enabled again. Okay, so this should re-enable this thing to our Spring Boot application. And actually, I think Mongo follows this pattern in the Spring Boot, or actually Spring Boot is following this pattern for this database because index creation is similar way. So people put index annotation on a document, okay, this index should be created and my query should be super fast, but actually without this property, it will be as well ignored. So it can be, sometimes confusing or people are not sure what is happening, why it's not created. Of course, we can create it manually, but that's other approach. There are two ways of creating transactions in Spring Boot. I think for all of the databases it's similar way. So it's well-known a declarative way of transactional annotation. We can also easily pass some additional config to our transaction here. So we can, for example, define read concern and other things. So it's little code, it's not like invasive, nothing is impacting our existing logic, let's say. We're just putting on top of the method something. And it looks quite neat, maybe. And then we have pragmatic way, which can look a bit more manual because we have to explicitly use transaction template object and then execute transaction manually, and we are putting a block of code inside this transaction by ourselves. So it triggers more thinking in people, and it's just makes that we have to make this decision more consciously. So I think that's really good, and I like this programmatic way a lot more actually, because everything can be more clear for people, especially when they are moving from another language, another framework, or they are not super familiar with how Spring Boot works actually. So it's just easier to control what is inside transaction. So this block of code should be executed inside transaction, should be a database transaction, and it's just more expressive for me. So then also we have a couple of benefits, like the method doesn't need to be public, because for transactional annotation, because of the way how Spring Boot handles those fancy aspects of like annotations, Yeah, it can be tricky. For example, transaction inside transaction. So we have method with transactional that calls another method with transactional. So only top level method will be taken into account and the other will be ignored. Also, like self-invocation of a method with transactional, it also works with some specific mode or some other magical Spring Boot setting. So actually, it's really usually harder to understand when transaction is created, when not, how it actually works, and yeah, people can make more errors and mistakes because of this. So now let's have a look at the minimal Spring Boot configuration for supporting transactions. So, okay, we have database, we have some logic, we would like to create a transaction to support this data consistency in our service. So then first, as I said, we have to create Mongo Transaction Manager, which will enable those transactions in Spring Boot. So we have to add a bin to our system. Yeah, actually, this line is not needed, so just config class with a bin, so singleton object basically, that we can use in every other class. We can inject it using dependency injection, as you know. So it's like this. And also on this level, we can apply any configuration to our transaction. So read concern, write concern, and read preference. So basically, it's all about how many nodes in this replica set confirm the operation. Because usually in Mongo there is some replica set. It has primary node and secondary nodes. Usually all of the writing is done on the primary node, and then everything is synchronized to other nodes. So at the end, every data should be like replicated and confirmed by every node. So also we have to ask ourselves, do we want to read the data fast? But maybe sometimes we read data that are not up to date exactly, or maybe we miss something, or maybe other transaction changed something. So those are the questions, and then we can read what are those concerns, let's say, or settings for this transaction, and then we can apply what we actually need. So it's like maybe a bit of a topic on its own. And then we are adding Mongo transaction template, which is the thing that we will use to actually execute the transaction. So here we can also set, is it a read-only transaction, or it is a transaction that actually adds something to our database? And then we can set the isolation level. So then also it's good to ask yourself a question, what I want to read and how my transaction should behave. Like uncommitted changes should be visible or not. When I read twice the data inside my transaction, should it be different, or because other transactions in the meantime added something, or actually I want to have them repeatable and stuff like this. So as well, it's a bit of a reading on its own and like decision that we have to choose. And usually we are going just with defaults, but yeah, default for Mongo is usually majority of nodes, confirmed operation, and there is some default isolation level, like read committed, I believe. So also it's good to mention that in that setup, we're just using transaction template object. So no need for manual session management, like adding like to every database request session and stuff like this. It's all provided by the Spring itself. So when we want to be more low level, have more control, then you probably need a bit more logic, like maybe applying some session synchronization on the Mongo template or other stuff, maybe committing or rolling back transaction on your own, but it depends. So then summing up, we have small setup that is like service that injected Mongo transaction template, and then in our function there is no transactional, but explicitly we are saying transaction template execute, and those two operations should be inside transaction. Okay, looks fairly good, but of course in real life, in real projects, it can be different, or it can be confusing what actually is happening. So imagine we have this transactional annotation on a big service method. So we go to a new project, potentially created some time ago, so already legacy project, of course, and we have this, I don't know, 500 lines of service method, and on top of it is transactional. I would say it already is maybe a cold smell, or you can say that, okay, it will cause some problems in the future, especially when there is a lot of traffic, a lot of requests to our service. Because inside the service method, there can be REST calls, because we need to fetch the data to populate the database or enrich something. So we are calling some REST APIs, maybe third-party APIs, maybe it's a really old API. Maybe we are sending some Kafka events to the topic inside this transaction. So everything is inside the transaction because of the transactional method that basically starts transaction at the beginning of the method and ends it at the end. So first problematic scenario is indeed mixing database transactions with REST calls. So maybe it's obvious for you that it should be avoided, but yeah, I saw it so many times that potentially it's good to discuss it. Because here we have pretty, let's say, common functionality of some order creation. So customer created this fancy order in Alberheim, and then it has to be actually added. So then we are, of course, maybe getting some volume of the order. Maybe we need a delivery time slot for this order. It's our API, so we are in a fairly good shape. Maybe sometimes it's slow, but we can fine-tune it. Maybe fix something. Maybe do some async magic. It will be fast. Okay. And then we are actually creating order to the database, and we are synchronizing this order to the external third party, because I guess third party maybe is doing route planning, so then we have to provide those orders. But then, okay, this API is problematic. Sometimes it's really slow, maybe after 5-10 seconds it responds, but at the end it responds with 500 errors. And then suddenly the result is that our transaction is waiting, especially that everything is synchronous here. So the thread is just waiting for the REST call response. And actually, it can kill our database quite easily. So you can see as a result some Mongo timeout exception, it can be some thread pull exception, or actually connection pull exception, sorry. So connection pull exception, it can happen. So there is no more connections available because every connection is basically waiting for this REST call to be finished. So yeah, this basically makes everything slow and is really nasty. So better approach for this can be something like that. So choosing to use it manually, more or less. We are creating this, or actually injecting this transaction template again. We are executing only one operation in some transaction. It can be maybe, of course, call to multiple collections. So maybe we are doing many other things inside transaction, but they are just database operations. Maybe it's good actually to fetch the data first, so then we have this time slot, have the volume of the order, whatever, and then actually we are synchronizing the order to the external service. And then, of course, we need to be more aware, more focused on what we are doing. It's also good to configure this REST client to have some limitation, not hang for 10 seconds, but actually maybe timeout after 3 seconds, and also handle the worst case scenario, so this phase, and then maybe we have to set the order to retry, or maybe we have to delete the order, or actually we should flip those operations. So first we synchronize to external third-party system. If it's okay, then we apply change to our database if we need. Otherwise, okay, nothing in the database, nothing synchronized to the third party. It looks okay. So it should be less error prone in general, because people, when using this, will be more focused what I'm actually doing and not just putting something at the top of the method. And the second example that I have is this piece of code. So we can ask a question, what is wrong with it? Because, okay, we have this transactional method that can be something problematic or something, but in general, it's really small, simple method. It just does saving order to the database, our fancy Mongo database, because we got some event that order was created or updated or whatever, and then we are publishing order added event, because we would like to inform that, okay, we just added the order, other service maybe would like to read it, get the data for some other operations, some asynchronous logic can happen, or some, yeah, actually we don't care because we are just publishing, and actually that's Kafka benefit that we don't care what is the consumer of this event. But few questions maybe, because in general it looks quite good, because if we did something wrong with the Kafka sending, we configured Kafka wrong way, or maybe something else is failing, or actually our Kafka cluster is throwing some exception for us, or timing out on this topic, something strange is happening, and then we have the exception, and then the data will be rolled back. So then, in theory, it's okay. Nothing sent to the ward, nothing in our database, so everything is consistent. So it looks cool. But the question actually is, do we manage to commit this transaction before the consumer of this topic will start to consume this message? And in reality, it looks like, especially under a bigger load, that usually it's working fine, but sometimes not. So sometimes we have the following problem in our system, that this component 1 is creating the order with ID2, then we are sending this order added event to the Kafka, and then of course component 2 is a different thread, different application, different service, whatever actually. It wants to read the data straight away. So maybe using some order ID tool, it wants to fetch the data somehow via REST API, or I don't know, even directly to this Mongo database, actually whatever. Maybe one of the approaches is better, but let's say it just try to, okay, I got the event, I fetch the data. But then, order not found we got. So actually, it's like we are losing some orders. Something is not correct. Most of the times it's okay, but it happened to me that every minute or every couple of minutes, some order is not working properly, or it's not properly processed by this component too. So then, after digging into this, I discovered that basically the transaction commit is happening later than the consumption of the event. So basically, data change or change in the database is not visible to the component 2, which makes sense because it's just not committed transaction that is active just in this specific session. So better approach for this is just leveraging this atomicity of single document, because let's say we are just updating the order document, so we are focusing only here, so we don't need any transaction at all, I would say. And then it's always good to handle any negative scenario, like however we like, but again, in a more conscious way and actually have more control over what we are doing. Kafka failed or timed out, then maybe we set order for retry, maybe we remove it totally, or maybe we do something else. But in general, not mixing database transaction with Kafka sending or REST API is a benefit for us, not something that can cause problems. So it's always good to avoid it, I would say, and actually learning from this.
Yeah, just want to mention that Kafka can also be made transactional. Kafka can be made transactional.
So you say that you can like solve
the
solution?
Part of the transaction is not distributed transaction,
yeah,
but they are synchronized transactions. So if one fails, the other will be rolled back.
Okay, that would be cool. So that is
in Postgres, you can do that. You can combine Postgres with Kafka. I was going to ask if it's possible with Mongo as well. It's probably possible.
Yeah, maybe not. Interesting. I would need to check it because I haven't used it that way. But yeah, I will read on top of it. But yeah, that can potentially be a better solution indeed. So other better approach than this like classical transaction and yeah, making Kafka not aware that something like this exists. Because indeed, in that case, it can, because the problem I showed, and actually Kafka is very fast. So it's actually really funny that Kafka consumer is consuming messages faster than committing, transactional is committing the thing.
Yes, so put it in a transaction, it will not be read because on the consumer side, it will be read only when it's committed.
Yes.
So then
yes,
it will solve all your problems.
Yeah, yeah, exactly. I agree. Okay, that was the last example actually. So we have a couple of lessons learned, or maybe some guidance that can help you with Mongo database, with Spring Boot especially. So correct design is crucial definitely. So don't be afraid to put data that change together actually together in one object, because it should be fast, should be performant, but then you avoid transaction need and avoid the problem of this transaction creation and supporting. So then everything will be applied when you change one object, and some changes are applied in the array of objects inside. It will be just updated or not together as an atomic operation. And then this transactional can be actually avoided for me, because sometimes, depending on the team of course, but sometimes can lead to many confusion or some problems, especially when it's like recklessly used. So you can just try to use transaction template. Also, if you are using SQL databases, it's the same story basically, or similar story that you can use it more manually and have more control and put explicitly the code inside transaction here in the execute method. And of course, we need to have this transaction manager explicitly set, not only application YAML config, but also some additional config is needed. And then, best is to actually be aware that mixing mixing those operations can be tricky. So like database can be really slow because something inside transaction is slow when it's a synchronous way. Perfect. So in general, I would say that Mongo database documentation is quite robust. It has a lot of information. So any specific setting or like performance or query optimizations, you can find it here, I would say. You don't need much more, I would say. And of course, Spring documentation. If you are new to this framework or want to deeply understand this transaction concept, how it's created, how it actually Spring does it, that based on one notation, everything is created under the hood. So of course, Spring Docs is useful. And that's it from my side. Thank you for listening.